So this week's project is taking me to the garage. My wife parks in the garage, I don't. My car's not nice enough. Mine's parked outside. Anyway, you see how much room there is right there? There's some room to back up a little bit, right? But it's actually not that bad. Sometimes my wife, just to make sure, she drives forward just so the garage door doesn't hit the back of her car. She drives forward a lot. And this little walkway right here, it's not much already. It gets really small and it's hard for me to walk through there. What a pain that is. But she doesn't want the back to be hit, so she just kind of drives up a little bit more just to make sure. Some people, to know exactly where they should park, they actually hang a string with a tennis ball, and when the tennis ball touches your windshield, then you know, like, I've gotten the perfect amount, so they like tie it all in the perfect spot for their car. I know my wife won't like that, and that's not real. I mean, that works, but I'm gonna do something electrical. I'm gonna create a sonar, like right here by that trash can I got empty, and it's gonna read how far away the car is. And once it gets to the right distance, I'm gonna put an LED on the wall, and it'll turn green, or like it'll turn red. So green means you can go forward, red means you've gone far enough. And I'm gonna do that, and I'm gonna 3D print a case for it. So that's what we're gonna do. All right, guys, for this week's project, I just need a few things. I need an ultrasonic rangefinder. Something like this is Sonar. I think they're called ultrasonic rangefinders or something like that. This particular one is a model, I can't read it with my eyes, SR04 or something like that. Junior year, you use stuff like this. Freshman year, you use the one with the plastic red cover on it, but it's the same thing. It's got the speakers and stuff on it. And it sends this ultrasonic wave that you cannot hear, and it measures how long it takes to come back. And it's constantly doing that like a few times a second. Then we need some LEDs. I got green, red, yellow. I might use all three. If I'm lazy, I might just do green and red. Then we need something to program, right? In freshman year, you use that big Cortex thing. Junior year, you use one of these, an Arduino Nano. Sorry, this is just an Arduino Uno. It's not very big, but it's about as good as the thing you use freshman year. These are about $20, brand new, name brand. If you get the generic, you can get these for like, I think $5, $6, $7, and they do all kinds of stuff. That's way more powerful than I need. This is an Arduino Nano, still way more powerful than I need. Look at all those wires and plugs on that. Those are called headers. I don't even need all that. I need 4 wires right there, and then maybe a few more wires for some LEDs. That's it. So I might use this little guy right here. I think that should be enough. I might use this one. So let's see. First thing I'm gonna do is start programming and get this working and prototype it, just see if it works. So first thing I'm gonna do is just wire this thing up. I found a diagram online how to hook up this sonar. So I don't want to make you watch me do it in full time. So here it is in 4 times speed, and I'm just kind of wiring it up, and I'm going to show you what I do to code it, and that's about it. All right, guys. Here's the tutorial I use. I just typed in this, which was already on. It was like written on the Sonar thing. So I just typed in this tutorial Arduino, because this is the Arduino. This is the device, and I just typed in tutorial. I found one. I should have used it probably. I found this one. It has nicer pictures. So it showed me exactly how to wire it. I wired it, as you just saw. And then it tells me where to plug them in, but you can see the pictures where to do it. Here's the code. I literally copied and pasted it. I did delete off, what did I delete off? I deleted something off. Right here. I deleted this centimeters because I'm not going to use centimeters, so I deleted it, although I could have just left it. I noticed that they made the pin mode for the echo pin input, which they already did here. So I deleted it off here. That's just an extra line of code I don't need. So I deleted it here. Then I deleted this since I'm not using centimeters. I don't need it to calculate the amount of centimeters. What it does is it takes the duration, the amount of time it takes in milliseconds for the signal to come back, or nanoseconds, I don't even know. And then it does a little bit of math, taking the speed of sound in account. Taking the speed of sound, it does the math, and then it'll turn centimeters in. Then it tells it to print centimeters. That means show me on the screen. I deleted this line of code off right here, and I left the inches on here, and I deleted here where it says to print the centimeters. I deleted that off as well. And then it says wait 250 milliseconds. So a quarter of a second, then do this all again. So it does it over and over again once every quarter of a second. I might increase that a little bit. So anyway, here's the code. I copy and pasted it in here, and you can see I did it. So I'm going to upload it right now, and let's see if it runs. And here's the serial monitor where it prints. So let's see it print. There it goes. I need something. Let's see. I'm going to take my phone right here and kind of. There you go. That's about 5 inches away. That sounds right. Let me move it further away. Further away. 7 inches, 8 inches, 9 inches. That's right. I move this out of the way, and that's how far away I am. But it looks like it sends the signal into my body, and maybe the fat on my stomach is absorbing the signal and not sending anything back. So it's like, man, you must be 1,000 inches away. I think it's just maybe my clothes is soft, and so it absorbs the sound wave and doesn't bounce off of it. So it needs to be something a little bit hard, but a car should be fine. So I think it'll be fine. I know it works great on my phone. See, it's like clean. Once I move this out of the way, it starts to kind of glitch out. It's kind of like you're like 9 inches away. Sometimes it gets a signal, sometimes it doesn't. But looks like it works so far. Now I just need to write an if-else statement. If this distance is, further away than this, turn the light on. Otherwise, turn this other light on. So I'm going to do that right now, and let's see if that works. All right. All right, well, hopefully you guys can see this. So here it is. I'm not going to use my shirt, obviously, on my body because, as we know, it absorbs signals and doesn't read a good value. So here's my phone, and it's green, means the car can keep going forward. And there we are. It's yellow now, orangish yellow. And I should have a few inches to play with. When it gets within 4 inches, it'll turn red right about here. There we go. So that means don't move it forward anymore. So obviously I'm going to change these values. Right now it's something like 8 and 4 inches from there to there. So 8 to 4 is right here is going to be in the orange. You can see that it's staying in orange as I move right around here. Orangish right there. I have 4 inches to play with. If it goes further back, it stays green. And if it goes really close, up to 4 inches and closer, it stays red. So I just got to change those values around, and then I got to design something to 3D print to hold all this. So this is Fusion 360. It took me over an hour to do all this. So I'm not going to even bore you with even a high-speed thing of this, because if I flew on high speed, it would still take like 10-15 minutes of watching me do stuff. I'm looking stuff up online, trying to figure out how to do stuff. So that's the bottom thing. I'm really proud of that one. That's the one that fits really nice together. That's for the LEDs, the 3 lights, red, green, and yellow. So they go in there. And that's the lid for it. And that thing fits perfect. It almost snaps. I didn't design it to snap, but it certainly feels like it does. It kind of friction fits in there, and you got to pull it out. And it's like doesn't even really require glue, except it's so tight that I just didn't want it to pop out. So not too bad. This is the base for the Sonar. Man, that thing, those 2 circles lined up, I used dial calipers. I put a little bit of tolerance in there, which means I added a little extra space just in case kind of stuff. Tolerances we learned about in 10th grade. That is the top of it. I just made it so 2 screws hold it. I ended up just putting some hot glue and stuff because I misaligned a couple of holes and stuff like that. But in the end, not too bad. Those holes, not this one. Wait, not that one. That was for the 2 circles you just saw. This one right there, that one, and that one. Those 3 holes there. That's for the Arduino. I made it to go inside, but I ended up putting it outside, and it was kind of opposite. I ended up drilling 2 holes to fix it. As you see, those 2 holes are countersink, so I can screw that onto a wall. Didn't end up using those either. And then I 3D printed them, and there's one, and there's the other. So I'm pretty much almost done. I 3D printed this thing. Look at that. That actually lined up nice. I was really impressed by that one. And I soldered it in here. And all that looking good. Arduino, I think I started drawing the pattern to go in here, but it looks like it's only going to fit underneath. So I'll have to drill a hole out with a drill. Now this I'm impressed by. I made some mistakes on it, but look at that. That thing's so small and compact. Let me open it up. Look at this. This looks like it was made by a manufacturer, you know? This is like, I'm pretty proud of this. There's some mistakes, but these things fit in there, and they push right through here, and the lights light up, and there's a little hole when you, in this box, there's a little hole, and I drew all this. I don't want to waste your time watching it. It took like over an hour. I made mistakes. I had to look stuff up, stuff like that. So I'm not going to bore you. Even at high speed, it would be boring because it would probably still take like 10 minutes to watch at high speed. So if I fast forward it. But you did see them get built on the 3D printer, so I did get that recorded, and that's not too boring, I guess. So next thing I got to do is wire this together, finish programming it so it's set for the distances for the car, not right here, and then I'll test it out, and then you'll see that right now. Okay, here it is. A big long cable so I can have the light somewhere else. That's just another project for later. But let's see how it is. I'm going to hook it up. Way more space here. And the sensor is pointing up at an angle there. I have to create something a little bit more permanent. It's kind of pointing, it's on the floor, and it's pointing at the car. All right. So the moment of truth here. Excuse the mess, but look at, there's the light right there. And I'm going to put it in drive. And I'm going to go until it turns pure yellow. I think that usually does it. Right there, it's about halfway point. That's a little too close, it turned red. Let me back up. I think just like right on the border is perfect. Let's see. Just enough room here. There's probably a foot. Okay, I'm in drive. This is try 2. Let's drive forward until it just changes color. Right there. All right, let's see what that is. That's what I'm looking for right about there. Where we're in the safe zone, but there's just enough room. All right, guys, that's it. That was a really long project. It was like a 12-minute video, 14-minute video. I don't know, it was a while. That project took me a long time. It was a lot to do, and probably not going to make any that long anymore. All right. Anyway, hope you guys liked it. Bye.